Hey YouTube. Today we're going to be adding on to last week's project. We talked about the altimeter here, or altitude sensor. I still have that hooked up. But today we have this guy here. It's a HCS04 Ultrasonic Rangefinder. These things are typically used for measuring distance. However, they do give us access to both the trigger and the receiver pins. So instead of measuring distance, we can measure the speed of sound. We have a card set up over here at exactly 5 centimeters from the sensor. So a signal at 40 kilohertz, I believe, is going to leave the sensor, bounce off the card, go into the other side, traveling a total distance of 10 centimeters. So if the signal traveled 10 centimeters in 400 microseconds, we'd know that the speed of sound was 400 meters per second. We're then going to take the information from the Arduino here, send it down to the Raspberry Pi, and we will be able to log it and use it with the balloon project. Now, we've got the breadboard set up here because this is still in the experimental phase. I didn't really want to use this in the first place, but I think it's going to work. I'm going to have all of this inside of the payload package. As to how I'm going to do that, well, that's a different story for a different time, so you want to make sure you subscribe so you don't miss that. I think it's going to be pretty neat. For now, let's head over to the computer and I'll show you how this works. Alright, so there's a couple of different programs I'd like to show you today. The first one here is just the speed of sound with the Arduino running right here on the laptop. We have the trigger pin on number 13, the echo pin on number 7. I did discover that to measure the time and the speed, they both need to be in the type of a float. We're going to open the serial port. We're going to set the trigger pin as an output, echo pin as an input. So first thing we're going to do is make sure the trigger pin is off, wait 2 seconds, and then we're going to turn the trigger pin high for 10 microseconds and turn it off. And then we're going to open up the echo pin, and the amount of time it takes that to come back is what that's going to return in microseconds. So that will be our time variable. And then to calculate the speed, we've got the distance here in seconds instead of microseconds, or the distance is going to be in meters rather than centimeters. So total distance of 10 centimeters is 0.1 meters. And then to calculate our time, we have to take the original time, since it's in microseconds, divide it by 1 million to get the actual amount of time in seconds. That will yield the speed being meters per second. Then we're just going to print the time, and then we're going to print the speed. We're going to wait 2 seconds, and then we'll start over. This is just going to run infinitely, and we'll be able to see the output for our speed. So I think I've already got that running on there, so we'll open up the serial monitor. There we go. So we can see that it took 296, 291, 297 microseconds. And then we can see the time here. And that's probably the closest I've had this. The speed of sound per Wikipedia is 343 meters per second. However, that's at 20 degrees Celsius, 68 Fahrenheit, at sea level. I am approximately 1,500 feet above sea level, so it's going to be a little different, but that's going to be pretty accurate right there. Let's go ahead and close this. Now, this whole thing does need to integrate with the altitude sensor. We only have one USB from the Arduino to the Raspberry Pi. So this is the program I wrote last week, and I pretty much just integrated the two, combined everything on top of each other, and let's upload that one. And we should be able to get altitude, air pressure, temperature, and speed of sound all coming out that one serial port. So let's open that one here. There we go, and that's formatted nicely. We should be able to read that just fine on the Raspberry Pi with the serial commands. So we've got altitude, air pressure, temperature, and our speed of sound. Perfect. So now I'm going to unplug it, and we're going to stick it into the Raspberry. And again, with the Raspberry, pretty much just integrated this into the same program that we wrote last week. We've got the same variables, same read line right here. The one thing that's different is that when we get the data from that line, we're going to have 4 variables now. So I just had to expand this array down here, this list, because this is going to yield four items rather than 3. We had to change this one here, add the speed of sound right here in the 3rd position of that list, modify the except lines in here, and then we're going to print it right down here underneath temperature. And we're going to collect that information from the serial port once a second. So let's see if this works. There we go. Got a couple errors in there. But for the most part, looks like that's running quite well. What did I set this for? 10 times? Yeah, we got 10 of them. And there's our altitude, our air pressure, temperature, and speed of sound. This one came out at 363. I did bump the card a little bit there, so the distance might have been a little off, but pretty consistent. I will have a more fixed way of attaching that all to the Pi. That's all I got for today, though. Next week, I think I'm going to get into some large-scale testing with this. This is about everything I want to do physically with the hardware. We need to test some more things with the tracking system. I think I'm going to submerge the entire thing in a box full of dry ice. Not next week, but that's something that'll be coming soon. Until then, make sure you subscribe. Let me know what you thought below, and I'll talk to y'all next week. Thanks.